Hello, welcome to Real AI Now, the podcast about real application of AI in business brought to you by TrueImpulse. My name is Marc Giombetti and I'm the product manager of Ultra Time Series, and today I'm your host on this podcast. The topic about today's podcast is a very exciting one. We're speaking about privacy preserving and trustworthy AI. We're also going to go and touch upon the topic of data protection and privacy and how that can be ensured within models so that users accept the models. I would also like to ask you to subscribe to this channel and like the episode. We're available on YouTube, Spotify, Apple Podcasts, and Google Podcasts. And now I'm very excited to introduce my guest, Jianshu Weng. Hello, Jianshu.
Hello, Mark.
Hi. So for our listeners to know, Jianshu has many years of experience in academia as well as industry, reaching from the public sector, IT, finance, particularly in the field of machine learning and artificial intelligence. So in recent years, he has spent most of his time in putting AI and machine learning models in practice in real world use cases and advocating also ethical development of AI models and deployment of such models. He's very excited about the topics of explainability, fairness, robustness, and privacy-preserving AI models. And from his background, Jianshu holds a PhD from Nanyang Technological University of Singapore. He's currently located in Singapore, and he's the co-author of Artificial Intelligence and Ethics Governance Body of Knowledge. So thanks again. Welcome, Jianshu, and pleasure to have you on the podcast.
Yeah, thanks, Mark, for the invitation. Yeah, my honor to be here.
Okay, so great. So let's get started. So let's speak about the topic of trust. What is trust and why is it important to have trust in AI?
Yeah, so maybe let's rewind a little bit, right? I mean, why trust in AI, right? I guess probably there's probably two sides of the story, right? And then first of all, certainly, I mean, AI, in fact, in a way, it's already kind of embedded in a lot of our everyday kind of use cases. Right? Let's say you go to Amazon, I don't know what would be the equivalent of Amazon in Europe, right? But I mean, let's say, assuming you go to Amazon, you want to buy something, you're going to see some recommendations, right? Let's say, in a way that, in fact, the recommendation is kind of powered by some AI models on the background, right? So in a way, AI, in a way, is already kind of impacting our daily life, right? And I mean, Amazon is certainly not something totally new, just recent years. It's been there for a couple of years already. Right? But then the question is why the recent years there's a kind of seems to be a lot of interest in terms of AI and AI in our everyday life and the trust of the AI. Right? I think it's really because AI, I think it is not just deployed in recommendation system kind of applications. We see more and more AI applications in more high-stake applications. I would say probably seems like, let's say for example, banking, right? Or maybe finance. A lot of loan decisions and credit decisions probably based on some algorithm, some AI algorithm, right? And then maybe in HR and recruitment, a lot of times we see more and more application of AI in filtering the candidates or the resumes, right? So you can see, and then I mean, of course, more sensitive ones probably like things like autonomous driving, autonomous vehicle, right? I mean, we certainly see a lot of very sophisticated application of AI models, right?
So life is at stake.
Yes, certainly, right? So you can see that a lot of the applications, not like before, right? A lot more real life and production deployment of AI system, which in a way, it's going to impact our well-being. Sometimes can even be life, right? So I think that is one part of it. But of course, another thing, I mean, related to that is that certainly, I mean, if we can apply AI in a wider scale, certainly the contribution to the economy is tremendous. Right? I mean, I remember there was a kind of a report done by McKinsey, McKinsey research. I mean, they have some number was saying that maybe by in another probably 10, 20 years, 2030, right? The contribution by AI is probably about 3 trillion. Right? Certainly, it's really a very good vision that if you can really apply AI in the right way, right? So that is one time. I mean, you see a big potential of AI application, but at the same time, you see that, okay, now with more applications deployed and it's going to impact our well-being. Of course, I mean, start to get more cautious, right? So am I able to really just leave my well-being to some machine, right? Or some algorithm, right? Because you feel a little bit of uncertainty. But why there's a little bit of uncertainty? I think it's because we don't really know it well, how you're going to behave and whether you're going to harm us or not, right? So I usually, I mean, I kind of, sometimes I have also had a similar conversation with my colleagues, right? It's a bit like, I mean, this situation probably not totally new or totally unique for AI, right? I mean, for example, maybe when we talk about, let's say, travel now, I mean, COVID probably a little bit less restrictive. I mean, people start to travel again. So when we talk about travel, we usually will take planes, right? When in plane, is also like so-called autopilot system. In a way, it's also kind of an autonomous kind of system. In a way that our lives also kind of rely on the system as well, right? But we don't really have that level of phobias. We're saying, oh, if I'm going to enter into a flight, I'm gonna question, okay, whether that it is safe or not. I mean, of course, sometimes we do have the question, especially when the accident happens. So we do have the question, but we don't really have that level of a kind of fear or uncertainty. Right? So I guess now probably AI.
Maybe you can dig deeper. What would be the characteristics which make people trust in a system?
Trust AI, right? Yeah, certainly. I mean, that's the point, right? I mean, like, for me, I mean, certainly we want to know how the algorithm really works, explainability, right? Because I mean, a lot of times we say the AI behave like a black box, but I guess can we really like take a peek into the black box and to see what it really learns, right? That probably, I guess, will be the first starting point. I mean, like, is the algorithm in a way it is kind of expandable, right? That's one thing. Another thing I think is important is certainly, yes, I mean, you might be able to explain your model learning, right? But I think we also want to make sure that, again, the model learning is learning the right thing. So I think there's something that related to the robustness of the model, right? Because I think we see some negative examples, just like, let's say, for example, I mean, Tesla autonomous driving, right? In some situations, it just crash or maybe hit the human, right? It is really because I guess we know that when AI was trying to learn, AI is very good in terms of picking up patterns from historical data, right? But and then you're trying to apply the pattern into the new data. But what if, let's say, the new data in a way is quite totally different from the original data? Original data you used to train your model. How is your model going to behave? Right? That is in the realm of the robustness of the model, right? That's probably another aspect I would say is important. And more recently, I think it is also because the society is getting more and more cautious or concerned about data protection, right? Because AI model is learned from the data, right? And then the data is generated by human activities, right? So if you're using my data to build something, of course, I mean, are you really protecting the privacy of my data, right? So this is another kind of a concern over there. I mean, like, are we really doing using the model? I mean, building the model by using the data in a more what do you call it, a privacy kind of a cautious or the data protection cautious way. Right? So I think that to me is probably a few key elements in terms of building the trust in AI. Right?
Can you give our listeners an example where, for instance, privacy in an AI model was not preserved, and then there is a kind of leakage of information, and what the implications of such a leakage could be?
Yeah, I mean, a lot of times I think if we talk about privacy, right? I mean, there's especially, I mean, as I earlier on mentioned, right? I mean, now we see more and more applications. Let's say, for example, for let's say a lot of finance industry, we start to apply AI applications, right? There might be something which I mean, how do I put it? I mean, because when we talk about data privacy, a lot of times it's all related to the personal data, right? There will be certain things that which you don't really want. How do I put it? I mean, you don't really want it to be kind of used or exposed, right? Because I mean, typically when bank was collecting data, I mean, not just banks, right? A lot of organizations, when they're collecting data, what they're really trying to do, okay, I just collect whatever data which I want to collect. Yeah, kind of a dragnet kind of approach, right? But in fact, if you look at the data protection kind of a principle, let's say, for example, for GDPR, right? There's a lot of a requirement in terms of data minimization and what they call it, purpose specification, right? Because when you collect the data, you need to be, first of all, you need to be kind of specific about what do you want to collect this data for, right? And then you shouldn't be using the data in a secondary purpose. Let's say, for example, maybe initially when you're collecting the data, you're telling your user, I'm going to collect it for marketing purpose, right? But now you're kind of trying to apply it for another purpose, which is trying to maybe trying to identify more value from the data. So in a way, according to the kind of a data protection regulation, in fact, this is not something you should do, right? And that's why there's a lot of principle around data minimization as well, right? Because you should just collect data, collect those data which you really want, right? For those that you probably can't really justify, probably you don't even want to collect them, right? So that is in a way, and then AI in a way for me is just like another way to consume or to use your data, right? So you also need to justify if your original purpose doesn't really compatible with your primary goal, right? You probably shouldn't even be doing that. Right.
So I imagine basically, so you're saying, so for instance, I am a bank, right? I am collecting data. I want to build, I don't know, a credit loan model, right? To either accept or reject applicants. Maybe I collect or already have a particular clientele. What may happen is that there is also a bias in my training data, right? So that I am discriminating certain groups of people. Can you maybe dig a bit deeper into this kind of aspect, right? Like how does the data need to look like to be to produce a fair system?
Yeah. I mean, this is certainly a lot of a discussion around bias and fairness, right? But again, right, maybe we need to take a step back when we talk about fairness or maybe bias, right? So what do we really mean by fair, right? Because fair itself, it sounds a very simple English word, right? But technically, how are we going to define it? Because when you talk about we want to build a fair system,
how to measure it?
Yes, how do you measure it, right? That in fact itself is not really a simple question already, right? Because I mean, if you now go and study in the literature, there's probably more than 20 definitions of fairness, right? So I think, so that's why I always say, okay, when we really try to achieve a fair system, first of all, we need to answer the question, what do we really mean by fair, right? Because in different circumstances, you might want to apply different definition of fairness, right? I'll give a very quick example, right? I mean, like, there's a very famous example, right? I mean, in US, there used to be a system called compass, right? Used in the court system to decide whether, using the court system to decide whether one of the person is likely to kind of reoffend or not, right? And some of the judge decision going to based on that, right? And there was a kind of quite a big study or kind of a news around that is that there is a kind of a website, right? Citizen journalism website. They get some data and do analysis of the system. They were saying, oh, this system is biased towards a particular group of people, right? And they publish their findings, right? And then, of course, as a vendor of the system, they certainly need to make some justification, right? So they also kind of reply was saying, no. Based on our study, our system is not really biased. Our system is also fair, right? And then they also publish their findings, all backed up by numbers, right? But if you look, so I mean, of course, if you just look at the headline, right, you say, oh, the system is kind of a bias towards a particular group of people. Of course, there's a lot of concern about that, right?
So ethnic groups or like income.
Exactly, right? But if you look carefully about the two reports, in fact, both of them are correct. And why it is so is because they are just using different definition of fairness.
Okay.
Right. So I think to me, this yes. First of all, if you really want to build a fair system, first of all, I think we need to know what do we really mean by fair, right? And then probably in different cases, you need to choose what will be your definition. And then
like
if you
your
choose
core values of fairness, right? Yeah.
Precisely. Then you're gonna have a totally different outcome, right? So that's the first thing. And the second thing, of course, technically, then we come to how are we going to, because if you can define it, of course, we should be able to quantify it, right? After you quantify it, of course, it will come the step of mitigate it. Of course, when we come to mitigation, there will be a couple of different approach, right? Some, I mean, from machine learning point of view, is that when you're trying to build a model, maybe you can take the fairness as a kind of a what they call it, the penalty term or kind of a regularization term when you're building a model, right? That's one way to do it. Another way is that, okay, after maybe you can't really change the model, because the approach I mentioned just now is in a way that you are able to influence the training process. But sometimes you may not be able to influence the training process because you may just getting a already pre-trained model, for example, right? Then what you can do is sometimes you do kind of a manipulation of the model outcome. Then in a way try to make it behave more fair according to the definition of fair you choose. Right. So it's kind of it may not be that straightforward. Yeah.
Okay. So there's not a trivial answer to the problem, right? So
certainly it is not.
Yeah. So fairness is one aspect which let's say enforces trust, right? I think another one which is very often mentioned is security, right? What is security of an AI model, and what are the characteristics of a secure model?
Yeah. So I mean, of course, security sometimes it can be a little bit ambiguous, right? So I usually like to use the term probably robustness, right? Because it makes it easier to, because I mean, when we talk about security in a way, you can consider it as a kind of a normal cyber system. You certainly want to put together the
like
usual
attacks,
attacks and things like that, right? But I think AI model in a way, it is different from the traditional IT system in a way that previously for the traditional IT system, you just need to set up a security kind of a system, right? So as long as I can defend the access to the system, more or less my system is more safe. Right? For example, you put up a firewall and things like that, right? There's a typical approach we're going to use to protect a typical kind of a cyber system or IT system, right? But I guess the tricky part about AI system is because I mentioned earlier, right? AI system in a way it is trained by the data, right? And the data is kind of a trace of a human activity, right?
So it's a snapshot in time, right? Like
yes, precisely, right? Precisely. So that is the additional elements which we need to be careful when we are kind of saying we're trying to protect the system, or we try to make the system more secure or more robust. It's like, first of all, you probably need to make sure that your data collection process is not kind of a what do you call it, attack, right? Because sometimes that the model is going to depend on the data which you are collecting. If I'm able to pollute your data, I might be able to pollute the model which you are going to use. Right. So that is I would say probably the major difference between security in the traditional traditional IT system versus the AI system. Right? That's probably the first thing. And another aspect is sometimes that is probably on the robustness side, right? It is like your data collection process may be secure in a way that there's no malicious party into that. But I think at the same time we see a lot of news. I mean, the one I mentioned earlier on, right? I mean, Tesla, maybe autonomous driving vehicle. Sometimes we saw some news, right? There was doing some tests, and then in the middle, out of nowhere, suddenly there was a person riding a bicycle, right? And then it didn't really detect it, and then kind of hit into the cycler, right? So I think those are the things in a way. There's an aspect of how robust your model is, right? Because I think when we are kind of trained as a machine learning engineer or machine learning practitioner, I think we're always been taught, okay, you need to split your data into training set and a testing set, right? There's always a kind of assumption of the training data and the testing data should come from the same distribution, right? IID kind of an assumption, identical and independent are kind of distributed, right? So always assume the training data and your test data or the new data which you are going to apply your model, they are coming from the same distribution. But we all know that in real life, in production environment, it is never the case. I mean, the Tesla's case we mentioned just now, it is a good example, right? And there's a lot of other examples, like let's say originally it should be a stop sign, right? But someone just posts a kind of a sticker on the stop sign, and then
or I have a stop sign on my T-shirt, right? Which is not a stop sign.
yeah, precisely. I mean, a lot of the computer vision based systems can be easily kind of manipulated by some, we call it adversarial attack, right? So how do we really guard our system against this kind of attack? It is also a big kind of topic, right? Because I mean, historically, we care too much about something we call the in-distribution generalization capability, right? We didn't really pay enough attention to out-of-distribution generalization capability, right? So now I think people start to realize it. In fact, in real life, the data is going to just be different from the data which you use to train your model, right? So how are we able to quantify the kind of the level of uncertainty, how the model going to behave in a totally different environment. This is certainly something you also need to look into. And then you also help to kind of increase and build the trust in AI itself. Right.
So this is an interesting transition in the topic of ML ops, right? Machine learning operations and the life cycle of models, right? So we said, okay, the model is trained on a snapshot in time of data and a snapshot in time. But then if you don't do anything, right, your model is naturally going to be worse because the world around changes.
Right.
How do you ensure a proper life cycle of the model? What are the things and what are the potentially pitfalls once a model is out in production? What are the things you need to do?
Yeah, so I mean, talking about ML ops, right? I mean, ML ops certainly take a lot of inspirations from DevOps, right? But I mean, a very common and a very good practice in software engineering kind of realm, right? So in software engineering realm, a lot of times I think most of the times you care about your code, right? But I guess in machine learning, there's an additional 2 dimensions, right? One that we mentioned already is about your data, right? Because your model is trained on your data, right? And another aspect, of course, you still have your code there because you need to train your model, and the training code will still be there. And then sometimes it will be receiving some input from user, right? The interaction code is also there. So the code element certainly is still there, right? And then the third element is about your model, right? So I think that's probably the difference between DevOps and ML ops, right? To me, you have a lot more things to care about. Previously, you probably want one important thing you want to make sure is you're doing the versioning of your code, right? And then every time if you push a new change to your master branch or any feature branch, you probably will trigger some action. You need to scan your code and make sure that the coverage and security side of all your concerns, you kind of put it into your DevOps pipeline, right? So I guess for ML ops, yes, we are borrowing a lot of inspirations for DevOps as well, right? But because there's the 2 additional elements we need to think about, that sometimes we may not pay enough attention to it, right? A lot of times, I mean, we still probably use a lot of our practice in the DevOps kind of a practice and try to use it. But I guess that easily we're gonna overlook certain things, right? Because I mean, I always have a belief is like when ML, it sounds like quite sophisticated, but at the end of the day, probably we're just trying to answer one question, right? Which version of my data has been used to build which version of my model, right? Because a lot of times, I mean, the data may come from the same source, right? We secured our source, but a lot of times we do different kind of a feature engineering. Sometimes we even use different set of features, right? Different ways to do. I know we may create new features or do different kind of feature engineering, right? And then even for the same version of data, we might try different method or different algorithm to train our model, a different set of hyperparameters, right? So all this need to be captured because after your model deployed into the production, for the reason
it takes decision, right?
Yeah, true, right? And then also the model performance may drop, right? Because the data is simply just the data distribution shift, right? So I think we need to know, okay, if let's say, and of course another key element is about the monitoring piece, so we can come to it later. But let's say we realize if the model performance drops, we might need to trigger a retraining, or maybe we need to roll back to the previous version, right? Then all this kind of making sense is, okay, if I need to ever revert back to a previous version, which version should I roll it back?
Okay,
right?
So to summarize a bit things, like on one side, you're saying, okay, it's important to know which version of the model was out when, so that when somebody asks for an explanation, we can say, okay, well, the data used was this one, the parameters chosen were those, and this is the reason why we accepted or rejected your loan, right? That's one thing, so it ensures this trust. On the other side, it's like keeping up the quality because the world around is changing, and at some point in time, you need to, let's say, update your model with the latest reality so that it stays good.
Yeah. And also, I mean, just now we talked about robustness and fairness, right? In fact, all these things, you can also be kind of embedded into your ML ops pipeline, and very much like a DevOps, because after you push a new version, you will scan your code, right? You scan your artifacts. But I guess for ML ops, it's the same, right? So after a new version has been built, right? And then before you really push out to production, you might also want to scan whether your model is fair and whether your model is robust, right? So you can all do that. I mean, kind of in a way you can chain them all together, right? So I mean, at the end of the day, it's really like, to me, MLOps certainly is about tool, right? I mean, the tool will make our life easier, but I guess probably more importantly is a kind of a protocol, right? A set of protocol. Of course, the set of protocol will tie to the question we want to answer, right? So what do we really care about in the whole MLOps kind of pipeline, right? Which version of my data, which version of my model, whether my model is performing well, or whether my model is fair or not fair, right? Or whether my model is kind of robust or not robust. All this is kind of important questions we need to answer, right? And MLOps will also provide us a set of tools. I mean, of course, there's a lot of other different tools. I mean, every day is probably a new tool is popping up, right? But I guess fundamentally, we need to be clear about what we really are concerning, right? All those things we discussed just now, it all matters. Then we can use the tools kind of to channel all together.
So MLOps is more the engineering practice of ensuring that these kind of activities are done in a proper way, right?
Yeah,
I think
in a more automated. Yeah, we try to automate it as much as we can, right? Yeah.
Okay. So I think we started a bit from trust, and I also wanted to dig a bit in the role of AI ethics, right? And I wanted to pick your brain on the following scenario, right? And I think it's an example which is very often mentioned, right? So imagine a surgeon, right? So like you have a certain disease, right? And you go to a surgeon, a human, right? And he or she ensures you that, okay, well, we're going to do the surgery. And there's an 80% probability that you recover, right? So this is, on the other side, you could have the surgery done by an AI system, and you get 90% of recovery success, right? So like, what would you do, and what are reactions usually of people towards a human and the machine doing quite life-saving or threatening things?
Yeah. I mean, this is a very interesting question, right? I mean, if you ask me now, right, of course, I'll probably feel safer that a human is going to do the surgery for me, right? But I mean, that in fact is a very interesting thought, right? Because sometimes when we make the decision, we don't. I mean, if you ask ourselves, right, I mean, based on what we made the decision, right? Do we? I mean, because a lot of times we talk about, okay, if you really want to quantify, you really want to make a decision. I mean, the decision need to be informed, right? And they need to be quantifiable. But a lot of times, is it really so? Right? Just like I mentioned about, okay, maybe your chance of survival is maybe 80%, right? But who really give us the 80% number, right? I guess all those questions are very interesting. It's like, and a lot of times, a lot of people, they don't really question that, right? They just say, okay, they just feel, oh, if it's a human versus a machine, right? So maybe I'll just go for the human, right? Because maybe if kind of subconsciously we kind of trust human a little bit more than machine, right? But in fact, if we find deeper, right? Because sometimes we even realize, in fact, if you really leave our kind of a well-being or life to machine, right? It might be even more, in a way, it's safer, but safer in the context that because you can really know all the numbers, because I mean, you can really look into historical data, and then you can look at, and then just now I mentioned about the explainability, right? All those, in a way, it could be even give us more trust if you think deeper, right? Because a lot of times when you, let's say, for example, right, we don't talk about surgeon. A lot of times when you go to see a doctor, maybe because of flu or whatsoever, you go and see the doctor. But a lot of times, doctor will say, "Oh, yeah, this symptom, it seems like you're having a flu, or maybe you're having something, right?" But we just trust it because we trust the doctor is really doing their job,
the right thing. Yeah.
We don't really, we don't really further kind of a question it. Although we don't really have any number to back us up, but it's just in a way we kind of trust them, right? So I think that is in a way maybe going back where we started, right? Because a lot of times. We have some certain kind of a trust, but of course, trust sometimes comes from different source, right? But just now, when we're talking about AI or talking about autonomous system, I think we're just a little bit more cautious because it is non-human, right?
So the standards and expectations towards the machine are higher.
It is different, precisely. And sometimes whether this is a really I don't know, it's gonna be helpful or not, it's probably difficult to say, right? But at least, I mean, what we can see here is that we are having kind of a different kind of a set of criteria or standard when we are making a decision. I mean, if it is the kind of we're dealing with a human subject versus a kind of a AI or maybe a machine, right? I guess the way we make decision is kind of a different, right? So I mean, like maybe just extend a little bit on that. I mean, a lot of times when we are talking about, I'm just not talking about autonomous vehicle, right? And of course, now if you say versus it is a human driver, same situation. Maybe somehow he hit the one riding a bicycle.
Yeah.
Same situation. Now it's a human driver versus a autonomous driving, right? I guess our reaction will be different because if it is a human driver, usually I think we'll kind of justify it in a way, even in a legal aspect, right? I'm not probably a legal expert here, but I think my understanding from legal sense, a lot of times, as long as the driver can justify within a reasonable effort, he can't prevent it from happening. I think in a way he's well justified because suddenly out of blue and it's totally dark, I don't really see it, right? It is really a negligence. I'm not really like purposely trying to kill the one riding on a bicycle. But I guess when it comes to autonomous driving vehicle, I think our standard is different because we are kind of expect you should be able to respond in real time. Or I mean, like we're trying to question okay whether the model has a bit of a defect or things like that. So I think in a way it's like our kind of a benchmark or our kind of a criteria, it is somehow shift a little bit when we are dealing with a human subject and versus AI over there, right? So it's very interesting, very interesting.
I mean, the experience, if I may, so looking at this, right? I think you say fully. I mean, I'm fully with you, right? So like the expectations are much higher towards the machine, right? I think it's partially also because our legal system, right, has the base. Well, you do something wrong, you get punished, right?
Yeah.
Can you punish the machine? Okay, you may pull the plug of the server, but then your AI algorithm doesn't run anymore. But there is no punishment as such, right?
Yeah.
So I think expectations are higher, right? Like towards towards machine.
Towards machine, yeah. So that's why I mean, in a way, maybe going back to where we started, right? I mean, the trust. Maybe at the moment we haven't really established enough trust on the machine, on the AI yet, right? So that's why I think at the moment it is important because we're still yet to build the trust. But up to a point when the trust has been established, maybe we don't question anymore. Just like what we are just doing now, we just walk into
like the doctor.
Yes, to fully trust the doctor won't do any harm to us, right? But maybe now it is like we're still probably there's a gap in there. So that's why I think we need to really try as a practitioner. We still need to try hard to build, to help the society, I mean, human society, to have enough trust on AI and machine. Right? I guess probably let us I would say probably we are in that kind of a era at the moment, right?
Okay, I think those are perfect final words to summarize what we discussed about. So thank you again, Jianshu, for the interesting discussion on AI and trust. Thanks for joining the podcast. To our listeners, Real AI Now, please subscribe to the channel and link our episode. And thanks again to Jianshu. Pleasure of having you, and have a great day.
Yeah, thanks, Mark.